Come on, where's all my webcam people at? I only see your arm, Amy. And your thumb. Oh, Jesse, you just reminded me I was going to show something off today. Happy 4th. Oh, all right. People are celebrating. One moment.
My 6-year-old goes on YouTube and saw a meme that said that on the evening of May the 3rd, you should put out chalky milk and chicky nuggies for Baby Yoda. So of course we had to put out chocolate milk for Baby Yoda last night.
Choco milk. BRB.
Chalky milk. Chalky milk.
Is it full of chalk or something?
I have no idea. He was insistent.
May the 4th be with you all. Welcome to another week of online Zoom class. People are celebrating this holiday in their own way. Jesse has a Star Wars background. Amy's wearing a Star Wars t-shirt. Colin grew a mustache.
It's true. That all happened in 1 week.
I was trying to think of a Star Wars character with a mustache. I can't think of one off the top of my head.
Lando Calrissian.
Lando.
There you go. That's what that's for, right? It's a Lando mustache.
Yeah, perfect.
Wait, so is this class a trap? Did the stormtroopers arrive here just before I did?
Yes, 2 hours before.
For the occasion, I thought I would share a gift that one of my former students handed me on the last day of the semester a couple of years ago. This is a 3D printed and then hand painted lightsaber. A more civilized weapon from a more civilized age.
That's pretty legit. I have
Yeah.
one year for Halloween, I was Ray, and I have a Ray stick that I made out of a curtain rod.
Mm.
And when we first started social distancing, I went for a walk with my friend, and I would push it toward all of the people we thought that we knew to be 6 feet.
Oh. Good
Like
idea. I would use this for that. I really enjoyed this gift. The only problem with it is there's no beam that comes out. So if any of you guys are thinking of a gift, if you could give me the beam.
The killing side of it.
Yeah. The laser.
I do have one, but the battery doesn't work so well.
No, I don't mean with a battery. I mean like a real laser that would shoot out.
But we would need a huge battery supply and a metal rod to heat up to the point of fire.
Oh, Amy's got a plastic one. All right, well, much as I would like to just continue discussing Star Wars, I'm going to have to force an end to this so that we can get back to algebra. Big week. You know what happens on Wednesday?
The death of our grades.
Hopefully not. Hopefully the building up of your grades. It's like building a new Death Star. And hopefully this one won't have a weakness that can be exploited.
It has to have a weakness to be exploited.
Hopefully this one won't have the weakness. Never understood why they would put trillions of dollars into an enormous giant spaceship and then build it with a weakness. So all someone has to do is fire one missile down one hole and just blows the entire thing up. But anyway, this is exam week, Wednesday through Friday. There'll be an exam available for you guys to take on Canvas. I've already mostly created it. I'm still putting some finishing touches on it, but I pretty much know what it looks like. It's going to be completely multiple choice, except for, I think, 2 questions that will ask you to give an explanation. The only problems that I can't really make multiple choice are the ones that ask you to interpret the meaning of something in context, where you have to write a sentence. Other than that, it'll ask you find the model that fits this situation, and then you'll have to pick from a selection of 6 options, like which is the right function. And it'll say, you know, ask a specific question about that function, and it'll give you different possible answers. And so you need to do the math. You should have paper in front of you to work things out. But then you're just going to choose the correct answer. So there are pluses and minuses with that. The minuses makes it very difficult for me to give partial credit when it's multiple choice, because I can't see the logic, the reasoning behind it. But the plus is, if you do it and you get an answer and you see that that answer is in the list, then you're pretty much confident that you did it right. It would be a huge coincidence if you did it wrong and just got an answer that happens to be on there. And actually there will be partial credit, in the sense, let's say some of the problems have multiple steps. So let's say you do part A incorrectly, you get that one wrong. But if you do the second one correctly based on your answer to the first one, then I will still go back and give credit for that, even if it's technically not the right answer. But if it's correct based on your answer, you see what I mean? So in some cases I can see like where you got that answer from, because it's maybe you did this part wrong, but then you still did this part correctly. And I'll try to give as much partial credit like that as I can. So today we're going to spend a big part of the class going over the review sheet that I sent you guys last week. But first, we're really running out of semester. So I wanted to start off by going back to Unit 3, Activity 1. And we almost finished the class discussion, and my computer froze like right at the end last time. So I want to just finish up the last part of that class discussion.
Is your air conditioning that good?
Air conditioning that good? I gotcha, because my computer froze. This kid's got a lot of metachlorians, I tell you. Come up with humor like that. So let's recall the whole scenario here. The manager of this museum was thinking about increasing the price of admissions, but she found that if she increases the price, then fewer people will come to the museum. And in this whole problem, we defined X to be the number of $1 price increases. So X is the number of dollars that the price is increased. And then the function R of X represents the revenue. Weekly revenue, I think. And we were given that function, and we also talked about how to derive it. So when I finally read the problem correctly, I showed you last time where that function comes from, that it is valid. And we were given the graph of that function. And we said this is an example of a quadratic function. And with the graph of a quadratic function, unlike linear functions or exponential functions, they can go up and then come back down, or they can go down and then come back up. This one goes up a little bit and then comes back down. And we discussed that if she raises the price a little bit, the revenue will go up. But if she raises the price too much, then fewer people will come to the museum and eventually the revenue goes down. In fact, we talked about the x-intercepts. One was -6, which means if she reduces the price by $6, there would be 0 revenue. That's because the current price is $6. So if she reduces it by 6, then she'll be charging $0, letting everybody in free, so there'll be 0 revenue. Or if she raises the price by $13.33, I think it was, then nobody will show up to the museum and there'll be 0 revenue as well. We talked about the 2 points that share the same, or we talked about the other point that has the same y value as the y-intercept, which was the 1200, where the graph crosses the y-axis. And we saw that there's another point where the graph would cross 1200 as a y value. And so we decided that if she raised her price a few dollars, or I guess $7, a little bit more than $7, then she would have the same revenue as if she didn't raise the price at all. In both cases, the revenue would be $1,200. So yeah, we found the x-intercepts using the calculator. We found that point where the function was equal to 1200, also using the calculator and finding the intersection point. And the last thing that we didn't get to, which is going to be important when we talk about quadratic functions, is a special point on the graph called the vertex, which is the point where the graph of the parabola changes direction. It's where it either reaches a peak, as in this graph, or it reaches a lowest point if the graph was turned upside down. And the graphing calculator will find those points for us as well. So for this function, we want to find that vertex precisely and also explain what it means in this situation. So if we get out our graphing calculator, and first we need to have that function plugged in, which I no longer have it. It was -15x squared, I believe. Yes. -15x squared plus 110x plus 1200. And then we created our window settings to match what we could see on the printed page. X goes from -7 to +15. Y goes from -300 to 1500 with a scale of 100. and something is wrong. Perhaps I plugged something in. Ah, wait. Oh, I had times 1200, not plus 1200. Okay, that will affect it. My fingers are too thick for a touchscreen. There we go. Okay, so there's the graph reproduced as we see on the page. And you see where the vertex is on that graph? Says it's the highest point. Tell you what, let's go to the one on the page.
It looks like it's at just about 3.5 and 1400.
Okay, you're actually estimating the coordinates. So if we're looking for the highest point, it would be right about there. And again, it's the highest point. It's also the point where the graph begins to change direction, where it stops increasing and begins decreasing. And Amy's guessing that the x value there is about 3.5. Looks to me like it might be a little closer to 4. And the y value definitely does look like 1400. Looks like the curve just gets right up to that 1400 line. But let's find it precisely in the calculator. So now that I have the graph back up here, I'm going to press second and trace. Go to this calculate menu, and I've shown you how to use a few of the functions on here already. Which one do you think might tell me the vertex?
Maximum?
Exactly, and that's one we haven't used yet. But if the vertex is the highest point, then we will find it using the maximum function. If the parabola was like a regular U, it was upside down, then we would look for the minimum. And when we choose maximum, it's a lot like the 0 when we're looking for an x-intercept. The calculator says left bound, we need to move the cursor so that it's clearly on the left side of the vertex and press enter. Then right bound, we need to move the cursor over to the other side of the vertex and press enter. Probably would have been a good idea for me to increase my Y-max a bit so I have a little more headroom, but it's okay. And then he says yes, and we move the cursor as close as we can to the maximum, to the highest point, and press enter. And the calculator tells us exactly what that point is, so that we don't have to estimate. The point is 3.66666. Oh, again, since X represents money, let's round that to 2 decimals. And the Y value is 1401.666, which actually is also money. So let's round that to 2 decimals. And I just did something really bad. I rounded 666 to 66. And it should be 67. So that's how we find it in the calculator. But in terms of the problem, in terms of the situation, the vertex can often have a very significant meaning. Let's try to interpret this. Okay, we found the x-intercepts, which was the price changes that would cause revenue to be 0. We found the 2 points where the revenue was 1,200. Okay, that's a good amount of revenue. One of those points is if we don't change the price, keep it at $6, 200 people will come to the museum. We'll get $1,200. Or we could raise the price and still get $1,200. But if you ran a business or owned a business, what kind of revenue would you be seeking? Or what would you, shall I put this? What would you want to do with the amount of revenue that you are bringing in every week?
You'd want the maximum amount you could get.
You would probably want the maximum, which would be difficult these days. So on this graph, what point would represent the maximum revenue? Remember, the y-axis is the revenue. So what point on that curve would tell us where we have the highest y value, the most revenue?
The vertex.
The vertex. Exactly. In any situation that can be modeled with a quadratic function, the vertex can be very important because it could either tell you where that quantity is maximized or in other cases where it's minimized. And some things in life we want to minimize. We want to maximize revenue, but we want to minimize taxes that we have to pay. We want to maximize our grade in a class, but minimize the amount of time we spend looking for a parking spot. I was going to say minimize the amount of work we have to do, but that's not a good thing to say as a teacher. I try to come up with something else. We want to maximize good things and minimize bad things.
Well, actually, that would be a good thing. Because
Wait, where's the mute button? So if the price is increased by $3.67, because that's what X represents, the number of dollars of increase of the price, then the maximum possible revenue of $1,401.67 is achieved. Oh, remember, the price currently is $6. Wait, so let me phrase this in the form of a question. How much should she charge for admission to maximize revenue?
$9.67.
Correct. So this is telling us that the perfect price raise in order to get the most revenue is $3.67. And if we add that to the original price, we get $9.67. So you should charge $9.67 in order to maximize the revenue. Let's really put it in context. The museum's revenue. Now, maybe $9.67 is kind of a weird price to charge, especially if people are paying cash. So let's say she wants to charge a whole number. What would be the best whole number of dollars to charge?
$10.
Right. Did two people say that simultaneously? I know I heard Jesse's voice. It sounded like
I held up 10 fingers.
Oh, I'm looking at my screen right now, so I can't see the fingers. But yeah, notice if you look at this graph, that's the highest point is when this point is not accurate. When x is 3.67, that's the highest point on the graph, but anywhere nearby there is also pretty high. And the closer we are to that value, the higher it's going to be. The further away we get, the lower the revenue becomes. The whole graph is symmetric. And this is always true of the graph of quadratic functions. If we were to draw a line right through the vertex, a vertical line, the left-hand side is a mirror image of the right-hand side. So if we can't charge $9.67, then we'd like to charge the closest thing to it, which would be $10 if we wanted a whole number. Plus happens to be a nice round number. A lot of people would have $10 bills or $20 bills. That would probably be the best amount to charge. Any questions on finding that vertex and what it represents? Okay, I am going to assign this, but it won't be due until next week so that you can focus this week on preparing for the exam. But I do want to spend some time on one of the group problems. But group problem 1 is based on a concept that we skipped earlier in the semester. So you can just cross that out. And I'm going to put you in groups for a little while and have you guys work on problem 2. There's not a whole lot of math to it. It's mainly looking at the graph and interpreting it, and then using your graphing calculator to answer a couple of questions. So probably won't even do this all the way up until the break. I do want to reserve time to work on the review sheet, but maybe 15 or 20 minutes. I'd like you guys to consider this, and then we'll come back and review for the exam. So again, just problem 2.
I think he's back.
Yeah.
Yeah, he's muted and doesn't have a camera, but he's there.
I think it's because I took control of his meeting because you have all your controls open of your meeting. I could never do this in middle school. Actually, I could for a couple days, but this is my joke for you today, Professor Allen.
Trying to get it at constant calculus. Square.
I don't really
graphs.
know.
I got you. The horns are like what the graphs would look like.
Yeah.
Oh, cool.
All right. You can have control of your screen back, but you're crazy to not lock that down. You don't teach with a lot of 12-year-olds, do you?
No.
You were so lucky.
I don't even know how.
Actually, now I take that back.
Should have kicked him out.
No.
You say you're going to kick me out?
I didn't say that.
No, it was Tiffany.
I don't think I
know
I don't have that power. I could just steal your screen.
Luckily,
Mark
I
tried
have
to act like teaching 12-year-olds is bad. I mean, no, wait, 12-year-olds. I thought I said 12th grade. Never mind.
I did say 12-year-old.
Tiffany may want to kick me out, but I have the power over her grade. She got to remember that. Just kidding. That sounded really threatening or something. I didn't mean it that way. Okay, review sheet. I don't think we're going to have time to do everything on here. We'll do as much as we can. I think we should just do the first problem to kind of get started, and then if you guys want to give me requests, we can do that as well. So, I know Tiffany had a request, but then she just threatened to kick me out, so I'm not sure if I'll get around to it. The function p of x models the population of city A since the year 1900. In 1900, the population was 10,000, and the population grows 2.8% per year. Okay, what is the primary concept that we focused on in Unit 2 that this exam is based on?
Exponential equations?
Right. I would say just a little bit differently, exponential functions or exponential models, which are written in the form a times b to the x. And a is the y-intercept. Actually, you know what? Let's back up a moment. Let's define our variables. It says p of x models the population of city A since the year 1900. So the function represents the population in thousands. And x, as it usually does, should represent time. Although in that group problem you guys were just working on, x did not represent time, but it usually does in most of our examples. And the problem didn't tell us what units of time to use. Days, weeks, months, years, decades.
It didn't tell us, but it was implied years.
You are correct. Because it told us the growth rate in terms of years, so it would make sense to let our x variable represent the number of years.
Do we have to define our variables on the exam?
You know what? I'm not going to specifically test you for that, but it's really important in order to understand the problem. So I would say yes, just for your own understanding, but not specifically as part of the test. And number of years, just the number of years since the Big Bang?
Since the year 1900.
Right, since 1900. So we have a starting point at which we are told the population at that starting point. And that's what the y-intercept is. The y-intercept is the value of the function when x is 0, meaning no years have passed since 1900. And if no years have passed since 1900, the population would be 10,000. So that's our A, that's our starting amount for y-intercept. For B, the growth factor, that's what we want to multiply the 10,000 by. So let me just take you through a scenario here, okay? Just a little bit of kind of more general testing philosophy. Suppose I see that 2.8% growth and I say, okay, B equals 2.8%. But then I remember that I have to convert it into decimal form before I plug it into my function. So then I write P of X equals 10,000 times 0.028 to the X. Okay, so then I stop and I think, yeah, I think I'm correct. Well, you know, you can check things, you can play around with it, you can make sure that it's logical, that it makes sense. Let's try plugging in 1 into that formula.
Will we have time to check it in the exam?
You'll have 2 hours. So yeah, I think you'll have
2 hours for how many questions?
I don't remember the exact number off the top of my head. And some of them are multi-parters, so it's hard to say, but I think you'll have time. You know, you'll have at least 10 minutes or so for each problem. So if we plug 1 in, so that means 1 year goes by, right? 1901. Then this model would tell us that the population in 1901 will be 280. Does that sound like it grew by 2.8%?
No, it doesn't.
It does not. So with a little bit of thought and a check like that, we realize that this doesn't make sense. But too often, people don't do that step. They kind of just take the first thing that comes to their mind, plug it in, move on. So the point I'm trying to make is be thoughtful. Consider your answers. Consider whether they give you reasonable models that actually fit the situation. So why was that incorrect? What did I forget to do?
Add 1.
Add 1. Yeah. The base, if it's growing, the base needs to be larger than 1. Now, I always tell you to interpret the rate of growth, you would take the base and subtract 1 and then convert that to a percentage. This is the other way around. We're given the growth percentage. So instead of subtracting 1 right now, what we should do is start with 100% and think if we add 2.8% to the amount that we already have, then next year we're going to have 102.8%. And we still need to convert that to a decimal now by moving the decimal point 2 places to the left. That would give us a base of 1.028. And we could write P of X equals 10,000 times 1.028 to the X power. You see that now that the base is larger than 1, the population will actually grow if 1 year goes by. And it'll grow again if another year goes by.
I have a question about the comment in thousands.
Mm-hmm.
So it says it models the population in thousands, but then in 1900 the population was 10,000. Does that mean it was 10,000 thousands and we're supposed to use the number 10,000, or we're supposed to use the number 10 and then convert our answer to thousands? Thousands.
It means I'm not doing a very good job of modeling for you the proper way to take your exam.
Okay.
Because
Thank you for showing us what we could do on accident.
yeah. Yeah,
That's what I did do on accident.
and thank you for giving me that out. Yeah, I forgot I'd written in thousands, and the problem actually said in thousands. So the population was just 10,000. So A should have just been 10.
There won't be anything like tricky like that on the test, right?
Well, that's where the advantage of multiple choice comes in. So there's only 6 possible answers. Probably in this case, maybe all 6 of them would have the number 10 instead of 10,000. And if you forget, then you'll kind of remember. Or maybe half of them have 10 and half of them have 10,000. And then it forces you to think, wait, which one is right? And then hopefully you do the thought process that I didn't do at first here, that Jesse did, and then you realize which one is right. So that's the benefit of the multiple choice, right? You can kind of narrow things down. It can jog your memory and make you consider between this option and this option. If this was a written exam and you use 10,000 instead of 10, you know, I'd probably only take 1 point off. It's a mistake anybody could make, just forgetting the part that said in thousands, so you would still get most of the credit. So like I said, there's pros and cons when it comes to multiple choice. The multiple choice should help you determine the right answer and narrow it down. But then I can't really give you much partial credit on each specific question. So according to the model, what is the population of the city this year? And then I lied. Okay, you just caught me. 2 mistakes in 2 parts. I used the same review sheet when I taught this class in 2015. This year is not 2015. But my answer key, I'm assuming, is still based on 2015. So let's use that. So in the year 2015, which is not this year, but was this year at one time, X would be the number of years since 1900. Which is 115. So once we have the model, this is the easier type of problem in which we are given the input, the X value, and we simply need to plug it in place of the X, but be careful that X is an exponent, which is why this is an exponential model. So it's not 1.08 times 115. It's 10 times 1.028 to the 115 power. And that's 239.446.
You're unmuted. You're muted.
Thanks. And since this represents thousands, it's not the actual population. If we multiply that by 1,000, it would be 239,446 population. Every time I accidentally mute myself, it's Esmeralda who lets me know. Is she the only one who actually wants to hear what I have to say?
No.
I'd be lost without you.
Thank you. So sweet.
Please remember that when you're grading.
I'll try. Meanwhile, the other folks are just, oh, he's muted. Thank goodness. I don't have to hear him anymore. I see you nodding, Amy.
She's just incredibly fast.
According to the model, when will the population of the city reach 250,000? I don't know. Let's call up Melania and ask her. Get it? Melania Trump. She's a model.
Yeah.
Can ask her. She probably doesn't know though. Well, that means we are given the population, P of X. And it's the X value, the input that we don't know, that we're not given. What should P of X be?
250.
Right, just 250. Because now I'm remembering that it's in thousands. So it would just be 250. So going back to the, not to part B, because in part B it was a separate question where we were given the X value. But going back to the model that was circled up here, we can plug in 250 in place of P of X and set it equal to 10 times 1.028 to the X power. Okay, the X power is only applied to the 1.028, not to the 10. So whatever you do, do not multiply 10 times 1.028 first. The 10 is something separate from the exponent. And in order to solve for that exponent, we need to isolate the exponential factor, which means we have to get rid of the 10. And since the 10 is multiplied, the laws of algebra dictate that we divide by 10. So 250 divided by 10 is 25 equals 1.028 to the X power. Now, if our power, if the variable is in the power, what do we have to change the problem to in order to be able to solve it?
Log.
Log, right. That's just a universal rule. If X is in the exponent, there's no other way to get it by itself other than converting to a logarithm. So let's convert this equation to a logarithm equation. See, that mastery stuff that was on the mastery quiz is still going to come in handy. The base of this exponent is 1.028. The argument of the logarithm is 25. The logarithm is equal to the power, which is what we're trying to solve here. So X is now by itself. But we want an actual, well, we may want an actual approximation. Actually, at least in one problem on the test, I'm going to leave it in log form because I want to make sure you're solving it algebraically, right? The instructions here said solve this problem algebraically. So we could also solve it in the calculator. And you can certainly do that to check your work. But in some cases, I want you to use algebra, meaning use logarithms to solve for x. So this right here could be the final answer. But if we wanted to get an approximate solution with a decimal, then we would have to use the change of base formula and convert this into a division of common logarithms, where we first take the common log of the argument 2 divided by the common log of the base.
The argument is 25, not 2.
Hey, I said I don't want to hear an argument from you.
Yeah, don't you listen?
I mean, thanks. Log of 25 divided by log of 1.028 is approximately 116.562. Oh, it said up to 2 decimals. So it'd be 116.56 years, which starting from 1900, that would be about 2016 to 2017, somewhere in there. Any questions so far? Okay, so we have the model for this town's population. And then we're told that another town, city B, you gotta really admire my creativity in naming these cities, has a different model. What kind of model is this?
A linear model?
Correct. This one's a linear model as opposed to our exponential model, where x is the number of years since 1900. Use your graphing calculator to determine when the populations were equal to each other. So we want P of x. We want to know when P of x equals Q of x. And when it says when, it's asking us to solve for the variable x. So we have to plug in the formula for P of x, set that equal to the formula for Q of x, and take my word for it. There is absolutely no way to solve this using algebra, even with a logarithm, because there's this other x that's not in an exponent. So remember the one problem in the last lab assignment that said this is very difficult to solve symbolically? This is like that, except this one is not only difficult, it's impossible. So what we would do is go to the graphing calculator and graph the left-hand side as one function, graph the other side of the equation as another function, and then use the calc intersect function to find the intersection point. And when we find that intersection point, it's not the y value that we really care about, it's the x value that'll tell us how many years have gone by before those two towns have the same population. You can probably tell I'm kind of just planning to not actually do that. I think we've done lots of examples of graphing two functions and finding their intersection. And we have to pick and choose what we're going to have time to do today. So I think I'll skip that one. And let's take a break and come back at 8 o'clock. And then I'll start asking you guys if you have specific requests. And since Amy has given a couple of nice answers without demanding me to be eliminated from the meeting, I guess I will take her request since she mentioned it earlier. Oh, wait, I said Amy. Sorry, I meant Tiffany. No offense to either of you. Okay, so,
None taken, but I do have a couple of questions. So
okay,
thank you.
I'll go Tiffany first and then Amy.
See you in a few minutes.
Okay, see you guys at 8. Wow, Amy, you really have been doing some work on your house. See, you turned your garage into an old-fashioned soda counter. Whoa. Opera House?
Grand Staircase of the Titanic.
Oh,
How did you not know that?
sorry. So I said Amy's question would go first, huh?
Are we starting now?
Yeah.
Am I first?
I was gonna let you go first, but after you questioned my Titanic knowledge, now I kind of have a sinking feeling. All right, go ahead.
Okay. My first question is actually on the one that you didn't finish. I
Oh,
might put it into the calculator wrong, but when I calculated them, I actually found 2 points of intersections.
2 points of intersection. That very well could be possible, but it would only be the positive value that would make sense.
Oh, okay. Yeah, there's one on the negative side and one on the positive. So it would
Okay,
be the
so yeah,
positive.
it would just be the positive one because we're talking about after 1900. So
Oh,
yeah,
okay,
we're
got
not
it.
projecting like backwards before 1900.
Okay, and then this is the last one.
Okay,
2D.
2D.
I kind of just forgot how to do that.
All right. Well, I think we kind of need to go through the whole problem.
Okay.
This one should be quicker than problem 1, though. All right. So the exponential function d of x models the amount of a drug in your system. We'll just say amount of drug as a function of the number of hours since you took 40 milligrams. All right, we'll say since taken. The half-life of the drug is 8 hours. In other words, it takes 8 hours for half of the substance to be absorbed by your system. So our general plan is to look for a function of this form, a times b to the x. But there are some slight variations on that. In this case, a is the initial amount, which is 40. But it doesn't tell us, x is the number of hours. It doesn't tell us it decreased by a certain percentage every hour or increased by a certain percentage every hour. Didn't tell us it doubled. It did tell us that it cuts in half, but not every hour. So we need to be a little careful about how we deal with B. But A is certainly 40. Okay, but we are told that eventually only half will be remaining. what would we want to multiply 40 by so that only half of it is remaining? And the answer to that question is in the question.
0.5 or
0.5.
1/2.
Yeah, or 1/2. So we want to multiply 40 by 1/2. That's going to be the b. But it's not b to the x, because otherwise it would be reduced by 1/2 every single hour. But in this case, it's delayed. That 1/2 factor is delayed doesn't kick in until 8 hours have passed. So when we want to delay the effect of our base, we have to divide x by the delay factor, so to speak. So the base is 1/2, but not just to the x power, but to the x over 8 power. And that would be it for part A. How much drug will remain in your system after 10 hours? Okay, this part, since I wasn't asked about this one, we could kind of just set it up and then mostly skip it. This is one of those where you're given the input. So we want to plug x in. 40 times, Jesse said 0.5, which would probably be good to use 0.5 when plugging it into the calculator. And then we plug in 10 for x, and it's still divided by 8. So plug all that into the calculator, and whatever the calculator spits out would be the answer. Just be careful, make sure you plug like the exponent, put that in its own parentheses. And I guess we don't need to do C, but let's do it anyway because it's an important type of problem. So whenever the formula is not just a times b to the x, when it's one of these adjustments like b to the x divided by n, sometimes we may want to put it in the standard form b to the x so that we can determine what the growth or decay rate is per hour. And we've done that, we've practiced that quite a bit. So write the function in the form d of x equals a times b to the x. A doesn't change. Well, let's just write it the way we have it right now first. So it's x over 8. But to write it in this form, we don't want x over 8. We want x to be the power. But we're not allowed to just change the formula. So everything else besides that x still has to be included inside the parenthesis. The 0.5 and the 8, which is in the denominator, so it has to stay in the denominator. And so it's 0.5 to the 1/8 that will be separated from the x. And then we can go to the calculator and calculate that quantity, 0.5 to the parenthesis 1/8 power. And let's round that to 3 decimals. That gives us 0.917. Whoops, what am I doing? So the function is still function is still 40 times 0.917. But now it's just to the x power. And so now it's in standard form. Now we could answer the question, what is the decay rate per hour? Well, that represents 91.7%. That's why we know it's decaying. It's less than 100%, or the base is less than 1. But it's not a 91.7% decay. It's really how much lower than 1 is it? How much lower than 100% is it? So this is where we use the formula B minus 1. 0.917 minus 1 will give us negative 0.083 in decimal form. And if we convert that to a percent, it's negative 8.3%. So we can just say it's 8.3% decay per hour, or each hour. Now the question that Tiffany actually asked, part D, how long will it take until only 1 milligram of the drug remains? Solve algebraically, showing all work, then write an approximate solution to 2 decimals. So D of X represents the amount of the drug, which is already in milligrams, right? We don't have to change the units or anything. So we would just say D of X equals 1. Now we have a choice here. We have 2 different versions of this function. The one we started with using the half-life, or the one we just found in part C. And which one should we use? Doesn't matter. Either one would be fine, because they're basically identical. I would probably use the original. That would probably just be my preference, because that was kind of based on what was originally given. But either way would work. So if we set 1 equal to our function, now we have to do the algebra and solve for x. Again, it says solve algebraically. So similar to problem 1, part C, I think, that we did, we need to isolate the exponent. So we need to divide out the 40. 1 divided by 40 comes out even to 0.025 equals 0.05, still to the x over 8 power. And since x is part of the exponent, we have to convert it to a logarithm. The base is 0.5. The argument is 0.025. The power is x over 8. And we haven't completely solved for x yet. We still need to multiply by 8 to both sides. And we get x equals 8 log base 0.5 of 0.2025. And that is the exact form of the solution. But to get an approximate solution, we would have to apply the change of base formula. And multiply 8 times log of 0.025 divided by log of 0.5. And I think I will skip plugging that in. But if we plug that in, we should get the approximate solution from the answer key. Did that answer your question, Tiffany?
Yes, thank you.
Mm-hmm. Okay. Amy?
I needed a little bit of help with 6A. I completely blanked on how you take the annual interest formula and make it a quarterly.
Okay.
And I don't know why I blanked on it, but I blanked on it.
Hmm. You invest $5,000 in a savings account that earns 6% annual interest. Write a function f of x representing the value of the account if the interest is compounded quarterly. So anytime the problem is saying compounded quarterly, monthly, daily, there's a specific formula for that. And I've said that you guys are allowed to use your notes. If I was giving you a written exam, I would actually just give you this formula on the exam. But I figure you have your notes, so you can look it up. It's in Unit 2, Activity 8. And the formula is P times 1 plus R over N to the NX power. And we need to figure out what all of these constants are. P is the starting amount, the principal it's called. Which is the $5,000. R, in this formula, R is always the annual interest rate, which is 6%, but converted into a decimal. And what about N? The number of compoundings.
4.
Right, N would be 4, since it's compounded quarterly. So if we plug all those numbers in, we get f of x equals 5,000 times 1 plus 0.06 divided by 4 to the 4x power. And that would be good enough for part A. Now, to make the next parts easier, we could go ahead and simplify inside the parentheses a little more. If you take 0.06 and divide it by 4 in your calculator, you'll get 0.015. And if we take x, or take 1 and add 0.015, the base is just going to be 1.015. So this is just another way of expressing that. Sometimes it doesn't divide so nicely like that, but on the exam it will. So if you want to divide them and simplify it. So that way, when we get to part B, how long will it take for the amount of the value of your investment to double? If it doubles, the value of the account will be 10,000. And how long will it take? Means X is what we are being asked to solve for. So we take the 10,000 and plug it in for f of x. We get yet another equation like the last couple that we've solved. Now you could still solve this using algebra, but this time it says you may use your graphing calculator. to solve this. Since we haven't done one that way, why don't we do this one like that? Okay, but you still could solve using a logarithm. Divide both sides by 5,000, convert it to a logarithm, and then you'll have to divide by 4 last to get rid of the 4 from the 4x. Or if the problem is, if the equation is very difficult, in some cases, like 1D, you cannot even solve it algebraically. You can graph. I'm going to graph the function as y1 just because that was the original function. And I'll graph the other side as y2. And then the old intersection concept. So 5,000 times 1.015 to the parenthesis 4x. If I didn't put the 4x in parentheses, it would be totally wrong. And then I'm going to graph 10,000. And I need my window to make some sense. So I'll start x at 0 because I'm not going to go backwards in time. Don't really know how long it's going to take. So how about we try 10 and see if we need to adjust it as the x max. The y min can be 0. The account isn't going to go negative. We want to know when it reaches 10,000. So the y max has to be at least 10,000. 1,500 isn't going to cut it anymore. And I'd really like it to be quite a bit larger than 10,000. How about 15,000? And we could make the y scale 1,000 since y is going all the way up to 15,000. Let's look at that graph. Okay, there's our $5,000 account growing. There's 10,000. And I see that in those 10 years that I've represented, it has not reached 10,000 yet. But it's getting close. So I need to make an adjustment to the window. I need to see further into the future. So let's make the x max about 20 years. Then I'm sure that that account will reach 10,000. Yeah, it grows way past 10,000. And I can clearly see where they cross. So now I can go to Calc, intersect, first curve, second curve, guess. And I know the y value is 10,000, but now it tells me the x value is 11.638. Excuse me.
Bless you.
Thank you. Or 11.639. And that's how many years it will take. It's just my allergies, I swear.
It's all right. I'm right there with you. So on the test, when we do this, do you want us to round to, or do you want us to say it will take about 11.639 years?
Since it is multiple choice, you'll see how the answers are rounded.
Okay. So just go with the answer that's closest to.
Exactly.
Okay. Okay. Thank you. I appreciate you going. That was the formula that I always get confused about when I use that one. And now I will be able to remember that. So thank you.
Yeah, compounded. The word is compounded,
Compounded.
quarterly, monthly,
Yep.
unless it said continuously. Because that would be the next problem. And maybe we should start that. Yeah, because C and D is kind of like redoing what we just did, but with monthly instead of quarterly. So let's go, just since we're on this train of thought, let's talk about problem 7 as well. And actually, I had another thought when I sneeze. Did you guys notice that people always treat sneezes or react to sneezes religiously? Like before coronavirus, if somebody's near you sneeze, you'd say, "God bless you." And now if somebody nearby sneezes, you say, "Jesus Christ, get away from me." I stole that from a real comedian, Jeff Ross. I'm not taking credit for it. Okay, so suppose you invest $5,000 in a savings account that earns 6% annual interest. It's still compounded, but not monthly, daily, weekly, or quarterly, but continuously. So it's that word continuously that tells us that we need to use this model with E as our base. That's one of the more recent things we learned, so make sure you study that activity 8, that had the compound formula and then also the continuous growth formula or continuous decay. A is still the starting amount, which is 5,000. R is the interest rate, which is 6%. Still, just like in the last problem. Okay, remember, R is not the base. The base is E. R is just the rate. So we don't add 1 in this case. It is not going to be 1.06. Just 0.06. What if it was decreasing by 6%? What would R be?
Negative?
Right, then it would be negative 0.06. So in this model, R is just the rate, and whether it's positive or negative determines whether it's growth or decay. So that's about it. Then y equals 5,000 times e to the 0.06 t. And part A even had another question to it. It says in 10 years, so we're actually given a specific t value. I probably should have called this a function like f of t. So after 10 years, we would just plug in 10. That would be 5,000 e to the 0.06 times 10. And plug all that in your calculator and get the answer. Something occurred to me while going through all this, that obviously you guys need a calculator. And if you have a physical calculator, you know, that's great. But if you have an emulator on your computer or on your phone, in this context, I guess that would be fine. But remember what I said about cheating when it came to the mastery quiz? Same thing goes for this exam. Reaching out for help from a person or Googling, that would all be considered cheating. So try to be honorable students and honorable human beings as we resort to the only testing options we have during the pandemic. Other than me forcing you to have a webcam and me watching you while you take your exam, which I've avoided doing. In the fall, I probably will require that, but those students will know in advance that they signed up for an online class. So in a sense, you guys are getting kind of getting off easy, but like I said, try to be honorable in the way that you conduct yourselves. But you can access your notes, you can access a calculator. That's all fair game. So yeah, I'll let you guys calculate that. And how long will it take for it to triple in value? It starts at 5,000. When it triples, it'll be 15,000. So we set 15,000 equal to f of x. Why am I using t? Did we use? I think we never use t, even in our notes in the packet. I'm using t for time, but I mean, it doesn't matter, but no, we always just used x. So sorry, change those t's to x's. So 15,000 equals 5,000 times e to the 0.06x. First, we would divide out the 5,000. 15,000 divided by 5,000 is 3. X is in the exponent, so we have to convert to a logarithm. But the base is e. And the exponent is 0.06x. So what do we call that type of logarithm?
The natural log.
Natural log.
Right. So that's the natural log of 3 equals 0.06 times x. And then to isolate the x, we need to divide by 0.06. So our exact solution here would be ln 3 divided by 0.06. And if we need to approximate that, we don't need to do the change of base formula because ln is one of the logarithms that is in the calculator. So we can just calculate natural log of 3 divided by 0.06. And it would be 18.31. Years. And then the last question here. Very similar to problem, I think it was 4C that somebody asked about. What percent interest does this account earn each year? It's not really 6%. It earns 6% compounded continuously, which means it earns a little bit more than 6%. So this is one, it's once again one of those problems where my screen gets stuck. Oh, here we go. It's one of those problems where we want to write it as a times b to the x. In other words, we don't want e involved anymore. We just want 5,000 times something to the x. If we separate out the x, we're left with e to the 0.06. And that's a simple calculation. which gives us a base of 1.0618. Now that it's in that form, do you see the difference? You see how that is a regular base that has to be compared with 1. It's not in exponential E form or continuous form. So that's just a regular old B. And to find that interest rate or that growth rate, we subtract out the 1. We're left with 0.0618. And if we convert that to a percent, gives us 6.18%. So it's not a lot more than 6%, but slightly. Okay, other requests? I know you guys didn't even ask about that one, but just thought it would be good to do that last problem right after problem 6, so we see the similarities and the difference.
There are questions that ask to, oh, sorry.
No, it's fine. You go first.
It's not a specific number, but there's questions that ask to fill in the table. Will that be part of the questions on the test?
Very well could be. So I want you to study this whole review sheet, so I'm not going to say exactly this will be and this won't be. But any types of problems that are on here are fair game. So would you like me to go over that one?
No, I was just asking.
Oh. Marcelino, did you have a specific request?
Well, just the overall of question 5. Well, actually, yeah, 5.
Problem 5? Oh, the one that where we.
I forget how to do 5C also.
Okay.
So that's helpful.
Yeah, let's just start with 5. Let's go through 5 from the beginning. Suppose X represents the number of years since 1995. The table below gives the enrollment at a college as a function of X. The administrators at the school are not sure whether to expect enrollment to grow linearly or exponentially. Interesting thing, it's something I've been thinking about lately when looking at the news. I'm going off on a tangent here. But if you look at the graphs for the number of coronavirus infections, it's kind of cool. It's not cool, but it's like a combination of stuff we've learned in this class, because it started out growing very much exponentially in the US. Looked like it was going to just go crazy and just overwhelm the hospitals. And then when we started doing social distancing and lockdowns, and it kept growing, but now it's kind of growing linearly, kind of going up by about the same amount every day rather than growing faster and faster and faster. So it's kind of a application of stuff we learned in this class. You kind of see 2 different models there. What we'll hopefully see eventually is quadratic. Am I right?
Hopefully.
Yeah. All right, so let's suppose it's going to be linear growth. You can't always predict what's going to happen in the future, how something is going to grow. And you've seen that with the coronavirus, right? All kinds of different models predicting how many infections there are going to be, that some of them turned out to be wrong, some of them turned out to be too high, some too low. So if we assume linear, we assume it's going to keep growing at a constant rate. And it actually asks for the formula. But even without the formula, we could subtract 1107 minus 1025 and see that it grew by 80, no, it grew by, yeah, 83 in 2 years. Therefore, if it's linear, we assume it's going to grow another 83 in the next 2 years. So we can add 83. Then we can add 83 again. And we can add 83 again. But 83 is not the slope because 2 years are going by. So to find the actual slope in the equation of the line, we should pick out 2 columns from this table, like the first 2, and write them as ordered pairs. So this is really a review of Unit 1, which there could be something like this on the test. It's kind of combining linear with exponential. And if we name those points x1, y1, and x2, y2, we can calculate the slope as y2 minus y1 divided by x2 minus x1. We get that same difference of 83, but we see that the denominator is 2. So it actually increased by 41.5 per year. That's the slope. The y-intercept we can already see because we know when x is 0 that the starting amount is 1025, so we don't have to solve for b. And so let's write it as a function. So the linear model L of x, well, we're used to y equals mx plus b. So y equals mx plus b would be y equals 41.5x plus 1025. If we want to write it as a function, L of x equals 41.5x plus 1025. Okay, so that part was kind of easier, linear, something we've done a lot of. But now we're going to assume exponential growth. And the same thing, we want to find a formula for this. So this time, when we compare the first 2 values, we're not saying what would we add to 1025 in order to get 1107. We'd be asking instead, what would we multiply by?
Mr. Allen, I missed the last thing on the last question. Can you just scroll up by one little bit?
Oh, you think
Thank
you're
you.
so special. I'm gonna scroll up.
Sorry.
Sorry. So the question is, what would we multiply 1025 by to get 1107? You know, exponential would be like doubling or multiplying by 1.05 or multiplying by 1/2. It's not based on adding or subtracting the same amount every time. It's multiplying. So to find that, which is called the base, we could think of it like this. 1107 is going to equal 1025 multiplied by the base. So to solve for that base, we would divide by 1025. Now you could just go straight to this formula. Just say 1107 divide by 1025. Division is the opposite of multiplication, so that will tell us what we would have to multiply 1025 by in order to get 11:07. I'm going to put my calculator right on the thing Marcelino was copying. 1.08.
We can't see the calculator.
Oops. Now can you?
Yes.
Okay. So I divided those and I got 1.08. That means to get from 1025 to 1107,
Your Microsoft knows what time our class ends.
yes, it does.
I'm convinced of that now.
You're right. That's twice in a row that it just. Has it done that other days?
Yes.
Yeah, last week it did that for sure.
Well, I know last time it did.
If you don't mind, I'm gonna head out because my family started eating dinner, and if I don't get there, they're not gonna leave much for me. So I want to eat tonight.
I grew up with Monica. If you didn't eat fast, you didn't eat.
Exactly. No, but in all seriousness, it's usually like 5 or more people eating. So if you're not there, you're not eating with everyone.
Have a good night, Esmeralda.
Night, everyone.
Is that a Friends quote?
Yes, yes, it is.
Oh. Okay.
Glad you
Sarah,
got that.
I'm so glad you
good-
got that.
Have a good dinner.
I'll try.
I mean, I
I'm
didn't
too young to know friends.
Well, so are they.
I
I'm
just know the references because my friends like Friends, but I like How
Oh.
I Met Your Mother better. So whatever.
Ooh,
blasphemy.
I'm a Seinfeld man.
I loved Seinfeld. I watched every episode of that show.
Oh, I've watched every episode probably 30 times.
Mm-hmm.
There was a Seinfeld joke earlier tonight, and now I can't remember what it was. You said something, and I was going to comment a Seinfeld joke, but
Oh,
I didn't want to show my age. But now I can't think of what it was.
huh.
I have been using the I haven't a square to spare reference a lot lately.
Ah,
Yeah, some of the memes.
I don't have a square to spare. Actually, he didn't say it, but
No.
hey, Jerry, what do you say we multiply by 1.08 again, huh?
Hey.
So that's the pattern here. It's not adding a certain amount, it's multiplying
Multiplying.
by 1.08. So we can then take 1107 times 1.08. Giddy up. That would round to about 1196. Then we could take that number and multiply by 1.08. And that would round to about 1291.
So you want them rounded, not the exact numbers?
Yeah, and this one it said to round to the whole number because we're talking about populations. If I ever figure out why Microsoft Word always deletes my nines, I will be happy. For some reason, it just does not allow me to write 9. And then do it again, and it'll be 1395. Of course, there's got to be a 9 in it.
It doesn't want you to go all the way to 9 o'clock, that's why.
Oh, maybe one of my students programmed it then.
I wanted to go to 9 o'clock because this is helpful.
Hmm. Too bad. The programming. Part
Apparently my
B.
children are having a meltdown, so I'm gonna have to go.
Okay.
You should just tell them stop having a meltdown.
Oh, if only that worked, Marcelino. Good night, everybody.
Amy, we all know you're going to eat too. You don't have to come up with these excuses.
No, we eat dinner much earlier here at this house.
Oh. When you
But
say a
yeah,
meltdown, you're talking about a melted cheese that you're adding to your macaroni?
I wish that would be more fun.
Okay. Oh, before everybody leaves, we're not going to have class on Wednesday because that's the exam day. So you don't have to take your exam during class time, but I'm going to just not have class. So if you want to do it at that normal time, you can. And if you'd rather do it the next day, you can do that too. So it's going to be available from Wednesday morning to Friday night.
Thank you.
Mm-hmm.
Thank you very much. Also, telling them not to have a meltdown works in my house.
Okay, we get it. You guys
Sorry,
are
I
well
had to.
behaved.
It took a lot of spanking to get behaved.
Ah. All right.
Well,
So,
will we see our scores right after, like the?
no, because some of the questions, like one or two of them, you are going to have to write something and I'll have to go grade it
Okay.
later. And some other problems, like I said, I may give you points back if you did one part wrong, but then you did the next part right. So I think it'll probably tell you like how many points you definitely got right, but it may very well go up after that. So
Okay.
I wouldn't take too much stock into it. It's not going to be your final score. And so for this, I kind of just try to get a little creative to ask this a little bit differently. How many more students would be enrolled if it was exponential rather than linear? Oh, wait, I never finished part D. Okay, so we got the base, 1.08. And the starting amount, I think we can see that would be 1107. So the exponential model, A times B to the X, except it's not X. Why is it not just X?
No, but how come you don't start with 10? How come you don't start with 1025? Okay. Now answer that next part because I don't know that either.
Because it's every 2 years.
I did start with 1025.
Okay.
Because it's every 2 years, exactly. We're not multiplying by that 1.08 factor every year. X is not going from 0 to 1 and from 1 to 2. So that factor doesn't kick in until 2 years have passed. So just like the half-life problem, it's a delayed response. So in the formula, the X has to be divided by 2 so that 2 years will pass before it's multiplied by 1.08. And so for the last, so now we got that model. And I didn't ask, but we could always do other things with that, like figure out what the growth rate is per year if we put that in the standard form. But then this was just a creative way, this last part, part E, was just another way to say, what will the enrollment be? So if we find the exponential enrollment in 2005 and then subtract what the linear enrollment would be in 2005. So basically we're plugging 10 into both of our functions and finding the difference. Think of it as two separate problems. And then subtracting them. And if we plug it into the linear model, it was 41.5x, or 41.5 times 10 plus 1025. But I'm going to put that in parentheses because that's L of 10. And the first thing I wrote is E of 10. So I would just calculate them separately and then subtract them. So for example, E of 10 is 1025 times 1.08 to the, well, it's going to be the 5th power. But if you don't trust your mental math, you could plug the whole thing in 10 over 2 like that. So that's 1506 approximately. We round that to the nearest whole person. And if we calculate the linear model after 10 years, $41.5 times 10 plus 1025. That predicts there would be 1,440 students. And so if the exponential model, if it follows the exponential model, there will be 66 more students as opposed to the linear model. All right. We went over time, so I'll stop there. Due on Monday, May 11th.
Hi.
Unit 3, Activity 1, Skills Practice. And Unit 3, Activity 2, Lab Assignment. Hang on. Only number 1 through number 2.
Oh, I don't think
Not number 3. So that'll be due next week after the exam. And then, as I mentioned, no class on Wednesday. If you guys have kind of general questions about things or if you have questions about the review sheet before Wednesday, like tomorrow, you can still email me. Once the exam starts, I don't want to answer like specific questions because I don't want people to be looking at the exam and then trying to get help on it or something. But if you have still like a general question, I could still try to answer it through email. So yeah, that'll be available from Wednesday, May 6th at 8 a.m. through Friday, May 8th, basically midnight. And it's a 2-hour time limit. So whatever, and it does cut off right at the time, right at midnight. So don't start it Friday night at 11 o'clock, or you'll only have 1 hour and it'll just cut off. So please try not to wait till the last minute regardless, but give yourself
I have a question about the homework. Sorry, I think I wrote down the wrong lab last week. Is it lab is for activity 2, not activity 1?
No, I'm sorry, I just wrote that wrong.
Okay.
Activity 1.
Okay.
Yeah, we haven't even started going over activity 2 yet, so. Okay. Good luck, everybody, on the test.
Thank you.
Not everybody,
Great.
but those of you who are here. And again,
I have some questions about the quiz.
may the 4th
Thank
be with
you.
you.
Thank you,
You're
Mr.
welcome.
Allen, for everything.
You're welcome. Yes, Marcelino?
So how do I retake the quiz if it's possible?
Yeah, good point. I should have mentioned that today. I will, you know what? I'll make that available like the same time frame as the exam. So like tomorrow I'll make it so that you can go back and see the problems that you did wrong on this quiz, and then I'll make the next one available.
Okay.
And I'll email everybody informing them of that, since I forgot to mention it today.
It's all right. You're recording, so the after watchers will know.
What's that?
I said you're recording, so the after watchers
Oh.
will know.
Yeah, I usually cut out our individual conversations, though, when you ask me about philosophy or various miscellaneous questions. Maybe I'll keep this one in just for that purpose.